Alright folks, today we're working on one of my favorite objectives. I love doing linear programming. Example, Mary the math jeweler specializes in specialty earrings and necklaces online. She sells earrings for $30 and necklaces for $40. Earrings take 30 minutes to make and necklaces take 1 hour, but since Mary is a math tutor, she has only 10 hours to make jewelry because she does both of those things. In addition, she only has enough materials to make 15 total jewelry items per week. She makes a profit of $15 in each pair of earrings and $20 in each necklace. How many pairs of earrings and necklaces should Mary make each week in order to maximize her profit, assuming she sells all of her jewelry? So our first step here is to tell about what we're talking about. We have two variables. This is our two things that we're making. This is our two inputs, right? So our first input is we have earrings. So our X is going to represent in this problem the number of earrings. And the Y in this problem is going to represent the number of necklaces, because those are the two functions, those are the two things she's making. Necklaces. Okay, so our second step on each of these is to pull out our important information and talk about what our constraints are. So at minimum for all of our problems, we'll have at least two boundary inequalities and one profit functions. And we're looking for making sure that as we have real life problems, we have to have x is greater than 0 and y greater than 0, as we cannot make a negative amount of anything. So we're going to automatically list x is greater than or equal to 0 and y is greater than or equal to 0, because you can't make a negative amount of earrings and you can't make a negative amount of necklaces, and negative numbers are less than 0. So x and y have to be greater than 0. So I'll go look back up here and figure out what the other constraints are. And constraints is just a fancy word for limiting factors. So what are the things we have limiting? Well, it looks like we have time's a limiting factor, right? So earrings take so much time to make, and earrings take so much time to make, so time's a factor. And then I look back up at the problem again. I think I probably should have at least one more limiting factor. At minimum, we're going to have two, but more likely we'll have more than. So it looks like we also have materials. So it looks like materials is an also limiting factor. So time and materials. Okay, so when we're doing time, we're going to have something for the earrings, something for the necklaces, and then we'll have a total amount that we're dealing with. So for time for our earrings, we know it takes 30 minutes to make, and the necklaces take an hour, so let's just make sure we have it in one total unit. We're going to say half of an hour per earring, plus, let's see, 1 hour for necklaces, which we said what necklaces were y, so that's 1y, or just y. And we have a maximum of 10 hours a week, so our total is 10. We know that 10 has to be bigger than or equal to that time it takes for each individual one. And this is less than or equal to, because we can take less than 10 hours, that's totally fine, but she can't take more than, and she can also take exactly 10 hours. So this equation comes from that sentence right here, and this is hard for it to pull out. We've got half an hour, let's say, so necklaces take 1 hour and earrings take 30 minutes. And we have our 10 hours a week. We've got the same thing for materials. So we figured out the number of materials for a given problem by adding together our different items. So we're going to have x's for our earrings plus our y's has to be a total of 15, it carries over, 15 total items per week. So our total is 15. We can make equal to 15, and we can make a maximum of 15, but we cannot make more than that. So the earrings plus the necklaces have to be less than or equal to our 15. So this is our two different equations we're going to have for our constraints. So our next step is pulling back from our two. So we have
the graph down here. Let's figure out where our intercepts are. If you're watching this, you should already know how to do intercepts. This is the easiest way to graph standard form. So substitute in 0 for both x and y and find the result. Okay, so 0 times 1/2 is 0, so it says y equals 10. And plug in 0 here, half of something equals 10. So 20 has to be that something. Okay, the other equation, x plus y is less than or equal to 15. Again, x is 0, y is 0. Let's see here. So we put in x is 0, 0 plus something. Let's see, so 0 plus y equals 15, so y has to equal 15. And the same thing other way around, x plus 0 equals 15, so x has to equal 15. So it's like we only need intercepts of 20, so 10 on the y-axis, 20 on the x-axis, 15 on the x, and 15 on the y. So we don't need that big a graph. Let's count by twos. So 0, 2, 4, 6, 8, just going to count all the way up until I can easily get to all my points. 20, 22, 24, 26, 28, 30. And remember that the x-axis is the number of earrings. So y-axis going up, do the same thing. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. Remember, the y-axis is the number of necklaces. So, let's graph this line. We're going to say our point is 0, 10, so 0, 10. And our point 20, 0, so 20, 0. So this line is going to be across, it's equal to, so we can make a solid line. And we're going to be shading, let's see, solve for y. So again, it's slope-intercept form is the easiest way I know to figure out which way it's shading. So we're going to subtract 1/2 x on both sides, where y is less than or equal to 1/2 x plus 10. So that says we're shading below this one. Okay, so we'll just do shading below. And then let's see here. Look up. So I just did my 2 points. 0, 10 is right there, and 20, 0 is right there. And I connected those and made a point. Same thing for the other one. I've got 0, 15, so 0, and then be real precise about this. 15 is in the middle. And then 15, 0 is going to be 15, 0. And again, this is an equal to, so it'll be another solid line. Looks like they meet at a point. Okay, and if you use a ruler and you're really careful about this, then this graph will come out nicely. So then solve, let's figure out which way we shade. So we get subtract x on both sides, where if y is less than or equal to negative x plus 15. And when it says y is less than, we're going to shade down as well. So just like in our systems of inequalities, we're going to shade where both of them are shaded. Let's see, only one shaded here, only one shaded here, nothing shaded up here. So we have to shade down here. This is our acceptable region. And it looks like we have some vertexes. So all of these points defined in this region will work for either of these. So we can make none of them. We can make 2 necklaces, or 2 earrings and no necklaces. We make 2 of each, 4 of each, 6 of each. We want to make sure that we figure out where each of these vertices are. So if you're really careful when you're graphing, I mean super careful, you can just pull it out. So we've got a vertice at 0, 0. We've got a vertice at 0, 10. A vertice at 15, 0. And we have one out here in the corner, and we know that at 10, I'm going to go with 5. And we can make sure of this by plugging 10 into either equation and getting 5 as a result. And if we get 5 as a result, it should work. So we should say 10 for x plus, we don't know what y is, should be equal to 15. So let's see, subtract 10. So yeah, y equals 5. So that works. Okay, and I know I said 5. We're not going to have 5 here. That's a righto. Just cross that one off. So my 4 points, I just wrote 0, 0 from this point. 0, 10 is 0, 10. 15, 0 is right here. And then I just found this last one. You could use systems of equations and find this intersection if you wanted to. Or if you're really super careful about it, you can just graph it carefully and pull that out of the graphing information. So I have 4 possible points for my objective function, which is the thing on the back. So before we get to our objective function, we need to figure out, like, what was she asking? We've done all this stuff so far, but we don't really know what she was asking. She was asking how many pairs of earrings and necklaces should Mary make each week in order to maximize her profits. So this sentence right here tells us our profit statement. We know our profit is 15 per pair of earrings and 20 per each necklace. So if we're writing stuff down, we know that our profit equation, so input of both our number of earrings and our number of necklaces, is going to come from $15 per pair of earrings plus $20 per necklace. And you can put dollar signs if you want to. I mean, that makes sense, right? So we're going to evaluate each of those 4 points we have. So P of 0, 0, P of 0, 10, P of 15, 0, and P of 10, 5. And we're going to figure out which one of those is the biggest, because we're looking to maximize our results. So 0 of those and 0 of these is going to give us 0 profit. We're not going to be making anything at all. Okay, the second one,
we're looking to make 0 of the earrings, so 0 times 15 is 0, so 0 of those, plus 10 times each necklace, which is 20 bucks. Oh, sorry, 10 of those is $200. That's a total of 200 for that one. 15 and 0 is 15 earrings and 0 necklaces, so 15 times 15 is 225. 0 of the $20 ones is 0 bucks, so that's $225. And then 10.5 is going to be 10 of the $15 ones, which is $150, plus 5 of the $20 ones, which is $100, which is a total of 250 bucks. So it looks like this combination is getting together the most money. So our last result, we need to just write, like Mary should make 10 sets of earrings and 5 necklaces for a profit of, what's it, 250 bucks. So this should be our final result for any system of inequalities, and definitely for linear programming. It should have a sentence, because just because we said that earrings are X and necklaces are Y doesn't make it that everyone has to do that. If you wanted to reverse it, you get the same answer. Your graph would look a little bit different than this, but not significantly enough that it would be a problem. Okay, so we can get to work. Go ahead and cross off number 1. I just didn't print the right stuff on this page, so don't even worry about it. Work on number 2 and then onwards. All right, good luck, folks.